I'm going to discuss the allowable strength design of a reinforced concrete rectangular column based on eStructural Design Taichi found on the App Store. These are the input parameters required to design our rectangular column. Name of column like C1, C2. Type of column, type. Floor designation like ground to second. Size of column, width and length. Unsupported height. Size and grade of vertical bars. Size, grade, and number of sets of lateral tie bars. The strength of concrete used. Steel to concrete ratio. Load classification, and design loads. From the input parameters, get the required ratios and allowable stresses needed for our design, like N, the modular ratio of elasticity, M, strength of steel to concrete ratio, Fa, allowable axial stress in reinforced concrete, and Fb, allowable bending stress in reinforced concrete. Determine the design load of column by way of tributary load and the column weight itself. To design the column size, get the nominal load by increasing our design load with the reduction factor. After applying a safety factor, solve for the gross section area of our rectangular column and derive its width and length. From the gross section area, solve the area of steel required and its equivalent number of vertical bars. Check the maximum spacing for the lateral tie bars and follow the steps presented on this slide. These are sections of rectangular columns with eccentric forces acting upon it. Check the balance eccentricities of the column section and determine whether the design eccentricities required on a single x-axis or both x and y-axis are compression controlled or tension controlled. From the nominal load and eccentricities, solve the moments for axial bending or biaxial bending design and get the moment of inertia of the axis required for our design. Then solve the actual axial stress and the actual bending stress on single or double axis. Finally, test the adequacy of column section. For axial bending, the sum of actual axial stress over allowable axial stress and actual bending stress over allowable bending stress should be less than or equal to 1. For biaxial bending, the sum of actual axial stress over allowable axial stress and actual bending stress over allowable bending stress of both axes should be less than or equal to 1. The format of our design result are as follow. Design criteria, column size, vertical bars, and lateral tie bars. Thank you for watching. Please like, share, and subscribe to our channel.